Okay. Yeah. Okay, so for this lab 7, I went ahead and did the k-means clustering in 3 different clusters. So in this, I went ahead and used the data points from A1 of 210, MB4 of 58, and C1 of 12. So in this, I went ahead and gathered all the data points from 1 to 8, and I showed here the work and how I calculated the following using this formula right here. So for this example, since 210 between this data point, there's no difference, it would be a 0. So for the following data point of 5a, so the difference between 2 and 5 is 3, and the difference between 10 and 8 is 2, so 3 plus 2 is 5, and so forth. So once I did all the calculations for all of these data points, I went ahead and determined which cluster was more suitable for the data point. So whichever had the least difference between all these data points were as follows. So for this one, since the first data point 0, so this will go to cluster 1, 5, 6, and 4. So this one would be more equivalent. So we're going to go to 3, 2, 2, 2, 2, and so forth. And then so with this, since we already figured out the clusters for the table up here, went ahead and grouped them. So this is cluster 1 from here, gathered all the data points from cluster 2, which I have here, and then clusters 3, since there was only 2 data points, so we have the following. So in order to determine the new cluster data points for this, I had to add all the x and the y's divided by how many points were in each data set, and I went ahead and got this one for an example to create the new data point, which is 30 over 5 for both sides, which is 6 over 6, and this side 3 over 2, which is 1.5, 7 divided by 2, which is 3.5. So here is the new data point for the following iteration afterwards. So in this as well, we repeat the same iterations that we did in the previous one. So for here, I demonstrated the work as well. Basically calculate the difference from 2 to 10 to all these 3 cluster points. So for this, we repeat the same thing over again. So we're going to see which one is more equivalent to the cluster point that is asked. So this one repeats the same steps of 1, and then this one, I believe, is slightly different. No. But the thing that actually did change was this last data point right here, which will go to cluster 1. So this is the new cluster. So since this time we have 2 points that go to cluster 1, we're going to go ahead and calculate that. So we got 6 divided by 2 and 19 over 2. So we got the following data points for these clusters. So you repeat the same thing, you add all the x's and y's divided by how many points there are, and it gives you the following new data points. So for this, we basically did the same thing again. So in this, let me go ahead and add something real quick. Okay. So for like this one, I wonder if I should break it down a little bit. No, I'll just put it up here. Okay, so from the difference between 2 over 10 and 3 to 9.5 is that, like, difference between 2 to 3 is 1. So we're going to do 1 plus the difference between 9.5 and 10, which is just 0.5, which gives you 1.5, right? And then the following cluster, you do the same thing. So the difference between 2 and 6.5, so 2, 3, 4, 5. So that's going to be 5.5 plus, let's see, 5, 4.75, which gives you 9.25. And then here you do the same thing as well. So 1.5 to 2, which is 0.5. Let me go to this real quick. Okay, we're still talking about this data set right here. So you're going to do 0.5 plus, and the difference between 3.5 to 10 is 6.5, which gives you 7. Oh, which we have there. And you repeat the same steps over and over again. So with the following new iteration, since it's still within the same cluster, there isn't much of a change because you still have the same data points in each cluster of 2/10, 5/8, and what so forth. So for all 8 of these, since you see the clusters of all 1, 3, 2, 1, 2, 2, 3, 1, it's repeating the same thing over and over again. So this will be the final result for this lab. And yeah,